Here are the answers for the section A-7 homework. For question 1, we're asked to graph this. X times y is equal to 8. We can do this by making an XY table, but we need to make sure we have enough numbers in the table to represent this situation. Otherwise, we might get only one piece of the answer and totally miss the other piece. Let's try 0 for x. 0 times what makes 8? There is none. This is undefined. There will not be any points on the graph where x is 0. Let's try 1 for x. 1 times what makes 8? And y turns out to be 8. Let's try 2 for x. 2 times 4 makes 8. And 4 times 2 makes 8. And 8 times 1 makes 8. We could continue increasing the value of x. If x was 16, then y is a half. Notice that we haven't tried any negative numbers yet for x. Let's make sure we do that. When x is -1, y has to be -8. Or when x is -2, y has to be -4. Notice I'm starting to get some repetition of what happened on the positives. It's just that these are negatives. Let's graph our results. -2, -4 is located here. -1, -8 is located here. There was no dot that had an x value of 0. And then 1, 8 is up here. 2, 4 here. 4, 2, and 8, 1. Using the y-axis as an asymptote and the x-axis as an asymptote, we get a hyperbola branch. There will be a mirror image over in this section of the grid. Remember how we didn't include dots over here in our XY table, but we had put some mental thought into what they would be. There will be a dot here at there will be a dot here at -8, -1, and there will be a dot here at -4, -2, and then fit in a hyperbola branch. So this situation where two things are multiplied together and equal a constant answer creates hyperbolas. Number 3 has the same look. Two things times together equaling to a constant number. We're expecting to get a hyperbola. Let's choose some values. Notice that once again, when x is 0, there is no number for y that works. 0 times what makes -6? There isn't anything. This is undefined. That's why the y-axis line is an asymptote. Similarly, when y is 0, there's no number that works for x, and that's why the x-axis will be an asymptote. Let's choose numbers to the right of 0, like 1. 1 times what makes -6? And this is -6. Or if we chose 6 for x, then y would be -1. Let's work with negative numbers. When x is -1, what's y? It's 6. Or when x is -6, y has to be 1. We could also choose 2 or 3 because those would work out really good in our expression. Let's graph our dots. Left 6, up 1. And left 1, up 6. We have to skip over the y-axis because it's an asymptote. Now the ones that had positive x values. Over 1, down 6. And over 6, down 1. Now fit in a hyperbola. If this is not enough dots for you to draw a curving hyperbola, then put more numbers in the XY table. And here's this branch of the hyperbola. Number 7, find the value of C if these dots are in inverse variation. In an inverse variation, the two variables multiply together to equal a constant result. Let's use the first ordered pair to give us values for x and y. So x is 10, y is 25, and that equals to a constant. This makes 250. Now we can write our model again. X times y always equals 250. So what is c when x is 2? In place of x, put 2. In place of y, put c. And that equals 250. Therefore, c is 125. The next one is very similar. It's still an inverse variation, but it involves x squared. So x squared times y is equal to a constant. Use the first ordered pair to get values of x and y. For x, fill in 4. For y, fill in 3. This makes 48 is equal to k. So our expression is x squared times y equals 48. Now use the other ordered pair. This one's x and this one's y. So negative 2 squared times c equals 48. This makes 4c equals 48. So c is equal to 12. Number 15, same idea. Y varies inversely with x squared. So x squared times y is equal to constant k. Get the x and the y from the first ordered pair. 3/4 squared times 6 is equal to k. This makes 9/16 times 6 is equal to k. So k is equal to 3 3/8. As a fraction, this is 27/8. Now rewrite the model. X squared times y is equal to 27/8. And use the second ordered pair for our x and our y. So 4 squared times c is equal to 27/8. This is 16c equals 27/8. And now divide by 16 to get c alone. I'm going to take a calculator and go 27/8 divided by 16. In decimal form, the answer is 0.210 if you round it off a little bit. For the review assignment, we're going to run through our different shapes. So we need to use some judgment about what shape it's going to create. When it was a minus sign and equal to 1, that was the hyperbola. A is 5 and B is 3. The hyperbola is where you draw the rectangular box. So go left 5, right 5, up 3, down 3, and draw the box. Then draw the diagonals to that box. These end up being asymptote lines along the edges of the hyperbola. Now fit in the hyperbola. But how do you know if it goes sideways or if it goes up and down? When the x squared came first, which type was it? It was the sideways type. So right up along the asymptote and swinging down along this asymptote, and then touching at that dot and going up along that asymptote and swinging down along that one. Number 4, it's got the minus sign again. It's a hyperbola. This time the y squared is first, so it's the up and down one. A is 9 and B is 4. The A equals 9 is associated with the y, so it's on the y-axis, you go up and down 9. The B equals 4, this time has to do with the x, so go left 4 and right 4, and draw in the box. Now the diagonals. And now we'll fit in our branches. The y squared term was first, so that's the up and down hyperbola. Touching right there and going along the asymptote and close to that asymptote. And then touching here at -9, going right along there and right along there. Okay, now we have an equation. It's got x squared and y squared, but with a plus sign. So it's either an ellipse or a circle. For the general form of an ellipse, it has equal to 1 on the right side. Let's divide by 100 and take a look at the form that's created to see if it looks like an ellipse form. This would be x squared over 100 plus y squared over 25 is equal to 1. Yes, that looks like an ellipse. A is 10 and B is 5. The A equals 10 is associated with the x. So on the x-axis, go over 10 in both directions. On the y-axis, go 5 in both directions. Now draw in the ellipse. Okay, next one. It's got a y squared in it, but just an x. That's the parabola. Let's rearrange this so it has the correct form for parabola. On the left side, we want to have the linear variable all by itself. We want to have the letter x by itself. So let's subtract the y squared to make it move to the other side. We have 4x equals negative y squared plus 8y plus 16. Now divide by 4. We have x equals negative 1/4 y squared plus 2y plus 4. This looks like standard form, where A is this number, B is this number, and C is this number. So when we have standard form, there's a formula that gets us the vertex. Y vertex equals negative B over 2A. So negative 2 over 2 times negative 1/4. That's negative 1/2. Negative divided negative is positive. 2 divided by 1/2 makes 4. So in an XY table, in the middle row of the table, Y vertex is 4. What's the X coordinate that goes with it? Well, let's take our equation right here that has the letter X alone and substitute in 4 where the Y is. And then it will tell us what X is equal to. 4 squared is 16, and negative 1/4 of 16 is negative 4. 2 times 4 is 8, so negative 4 plus 8 is 4. And then we're adding 4 on the end, we get an answer of 8. So our vertex dot is 8, 4. Now choose numbers less than 4, like count backwards, 3 then 2, and count forward from 4, 5 then 6, and plug those numbers into the formula. So let's put in a 5. 5 squared is 25, and then we want to times by negative 1/4. That's going to make a fraction. So because that happens, using a calculator on this would be the best way to get the answer. It makes 7 3/4. And this one will be 7 3/4. Now substitute in a 6. This turns out to be 7, and this one will be 7. Now we can graph. On the x-axis, the numbers that we have in our chart are like between 7 and 8. 1, 2, 3, 4, 5, 6, 7, 8. And we have some fractions. We're going to be guessing in between there. Look at the y's. They're all positive, and they get up to 6. So 1, 2, 3, 4, 5, 6. Now let's graph the dots. 7, 2, 7 3/4, 3, and then 8, 4, and then 7 3/4 again, 5, and then 7, 6. Notice how this dot's lining right up above this dot with the 7. Remember those 7 3/4 dots? Perfectly straight above each other, lining up with where 7 3/4 would be on the x-axis. Now draw in the parabola. Page 308, write an equation for a circle. Well, what's the general form for the equation of a circle? X minus h squared plus y minus k squared equals radius squared. Here's the h, here's the k. So we have x minus 0.2 squared plus y minus 0.25 squared equals, and now r squared. R is a fourth, so what is 1/4 squared? It's 1/16. There's our equation. Number 16, graph this. Well, what shape is it? It's got x squared and y squared, so could be a circle, could be an ellipse, could be a hyperbola. We need to work on the form a little bit so we recognize what's going on. Let's take the existing constant term and add it over to the right side. X squared minus 6x plus y squared equals 16. Next, because there's an x squared and x term, let's use completing the square to make this into a trinomial, which will factor using the parenthesis pattern. Half of -6 is -3. -3 squared is 9. So add a 9 into the blank spot and on the right side. Now this trinomial will factor. X minus 3 squared plus y squared equals 25. Which equation form does it fit? It's got the x squareds and y squareds, and it's got a plus sign. Is it a circle or an ellipse? Which one is it? It's a circle. The center of the circle is 3, 0, and the radius is 5. One, 2, 3, there's the center, and then 1, 2, 3, 4, 5, the circle will go through here. 1, 2, 3, 4, 5, it'll go through here. 1, 2, 3, 4, 5, go straight up from the center, 5, it'll go through there. And 1, 2, 3, 4, 5, go straight down from the center, 5 spots, it'll go through there. Now sketch in your best circle that you can. That's pretty good. Why isn't this an ellipse? Well, what does an ellipse equation have on the right side? It's always equal to 1. So what if you were thinking that this is an ellipse and you wanted to make a 1 here? You would have to divide by 25, and you would get x minus 3 squared over 25 plus y squared over 25 is equal to 1. And then when you think about a and b, you'd get a equals 5 and b equals 5. That's the same distance. So after you find the center of what you think is an ellipse, you would end up going 5 units in all the directions. So what you think might be an ellipse is actually a circle because the value of a and b are the same.